All right, so we are going to be using our properties of logarithm. So we're into 5-5. There's only one more section of this chapter after this. So like we're coming closer to the end. And this means we need to remember our properties of logarithms, which you have worked with before, but we're going to write them out again. And then we're going to play with them all day. So our product property is when we have our, log base b. I'm going to write you guys. Just because they get in a mood sometimes. If we have two things being multiplied in our argument, we can separate them with addition. They'll become log base b of x plus log base b of y. So we can separate two things being multiplied with addition. If multiplication turns into addition, when we look at the quotient property, so we have division, we have log base b of some division, x over y. Multiplication becomes addition, so division becomes subtraction. Log base b of the top, the numerator, minus log base b of y. Huh?
It's like the same as exponents, kind of.
It's a similar vibe.
Yeah.
Well, because if you think about logarithms and exponentials are inverse functions, so they have very similar kind of properties. This one's not like exponents at all. The power property feels real weird. But that's when we have something in our logarithm, so a log base b of something to a power. We're using w in our power here. It becomes a coefficient. W log base b of x.
No, I think that's still like a power to a power.
Yeah.
That
Multiply.
becomes multiplication.
Yeah. But this becomes multiplication down in front. Yeah.
Yeah.
Yeah. It feels way different. To me, at least. If it works for you to think of it that way, absolutely rock on. Your brain is your space to play. And what we're going to do today is we are going to use these about a gazillion times. Oh my gosh, my friend who wrote these notes is absolutely insane. She fit 9 problems on one slide, and I'm like, no, thank you. Like, this is insane. It's gross. I just do 2. Then we have space to write and read and think. So what we have here, we need to switch this out of a square root and make it be an exponential so we can evaluate this. I want to figure out what this log equals without typing it in a calculator. So how could we write our argument not in a root? Log base 5 of what? How can I rewrite this 4th root of 25? 25 to the super close. You're right on it. It's actually the 1/4. Our index is the denominator. So this 4 becomes the denominator of our exponent. We can then use that power property to make this be a little less gross and bring that exponent down in front. 1/4 log base 5 of 25. I didn't lose anybody here. The reason we might want to do that is because log base 5 of 25, we can do that. That's 5 to the what is 25. Yeah. So log base 5 of 25 just means 2 times 1/4. This thing just means 2. So 1/4 times 2 is what? 0.5 or 1/2. So log base 5 of the 4th root of 25, you guys just evaluated without a calculator. Okay. So it's a very similar vibe on the right one. We've got 3 times log base 7 of the 6th root of 49. Ew. But we can rewrite that to get that out of the root. 3 log base 7 of 49 to what power? 1/6. The index becomes the denominator. We're going to use our power property to bring that down in front. So we have 1/6 times 3 log base 7 of 49. Log base 7 of 49? 2. So this whole thing just means 2. We have 1/6 times 3 times 2. So what does this equal? 1. That's a whole lot of work for 1, but it is what it is. And that's why we have all these logarithmic properties, is because trying to evaluate this back in the day when we had no calculators that could do logs, just log tables, being able to do it this way manually, so much easier than trying to look up log base 7 of the 6th root of 49. Gross. Okay, so we're using these properties to help us solve stuff. Man, you just check your recycler. All right. This one looks grosser. Mm-hmm. Yeah, the natural log of E, like we can deal with that. You can also use our properties for this. I can take this exponent and bring it down in front. I can take this exponent and bring it down in front. So that we have 0.5 times 36 ln of e minus 5 times 4 ln of e. What is the natural log of e? 1. So this chunk just means 1, and this chunk just means 1. So I have 0.5 times 36 times 1 minus 5 times 4 times 1. What is 0.5 times 36 times 1? 18. 5 times 4 times 1? 20. 18 minus 20? -2. So these look super complicated and they look super gross. They're not awful. They're not awful. They're very impressive. Like if you need to show off to family over holiday break, then here, do this. If you got a sassy uncle who thinks they're smarter than you, give him one of these.
My grandson has been like a math teacher for like all his life, but I don't think he did that.
That one would probably not be effective. All right. So sometimes we're not going to be asked to evaluate. We're just going to be asked to expand it. Make it as long as possible. So we're going to be using our properties to expand the expression. So we're going to start here with our quotient property, where we're going to take our log of the numerator, log of 5, and we're going to subtract. I always think of the division symbol kind of looks like a subtraction.
Isn't there an order you could do?
Numerator minus denominator. And aside from that, it's kind of reverse order of operations. We start from the outside and work our way in. So the first operation happening here is division. X to the 4th. I still have one more expansion we can do here. Power property. I've got this 4th in the exponent. We're going to bring it down as a multiplier. The Q is for quotient. I heard someone be confused by the Q. So we're going to have log of 5 minus 4 log of x. What's the base on this log? 10. Just checking in. If we didn't write it, it's got a base of 10. It's the common log. For all of them. If there's not a base written and it says log, it's got a base 10. We just don't write it on the common log. If it says log and it has a number, like the next one, it has a log base 3. And that is our fully expanded. That is expanded as far as we can. There is no more properties I can apply to this. So this is our fully expanded answer. So on this next one, we have to deal with our multiplication before we deal with our exponent. So we have to do our multiply and divide before we do exponents. It's like doing order of operations backwards. So when we're expanding, I need to do that multiplication first. So that's our first step on it. Log base 3 of 4, and our multiplication becomes addition. We're adding as many logs as we can. Think of it like firewood. tapping our log into more pieces. Log base 3 of y to the 8th. So multiplication becomes addition. And then we're still going to do the power rule. Our power property says this exponent comes down and is a multiplier. It becomes a coefficient. So we're going to have log base 3 of 4 plus 8 log base 3 of y. Questions on these ones when we're expanding? Because that is our final expansion. Because that's what we're going to keep doing for a hot minute here. We're going to be expanding. Boop. So they're going to start getting longer and longer the longer we go on this. So we now have log base 6 of x to the 7th over y to the 4th. So we start with our quotient property. I'm starting with this division symbol here. Log base 6 of my numerator, x to the 7th, minus log base 6 of my denominator, y to the 4th. Yep, we just did the quotient, so now we're going to do our power property. And it puts them down as coefficients. It brings them down all the way in front of the log. So we're going to have 7 log 6 of x minus 4 log 6 of y. And things like this are used in things like air traffic control. They'll use these kinds of things because if you think of flights, they only have so high they can go. But then they only have to look up log base 6 of x. They don't have to look up log base 6 of x to the 7th. It's easier to substitute things in when you're working with variables that are going to change repeatedly if you only have to change a little piece, not your whole formula each time. I mean, any more than type them in a computer, but still. Back in the day. That's our fully expanded form. Just so we're clear. There's nothing else I can do to expand that. The next one is slightly longer. Log base 5 of xy squared over w. So we're still going to start with our outermost operation. We are starting with our division. We start with our quotient property. So we're going to have log base 5 of the numerator, x, y squared, minus log base 5 of w. What are we going to do next? The multiplication next. Not going to do the power next. We got to do our multiplication first. So I got to separate these two guys because my x is not being squared. Only the y is. So we got to take our multiplication into addition first. So we're going to have log base 5 of x plus log base 5 of y squared minus log base 5 of w. Now we're gonna do our power property, where I take my 2 and bring it down in front of its own log. So our final answer is gonna be log base 5 of x plus 2 log base 5 of y minus log base 5 of w. These things get long. Really, really, really long. Yep, going back. Sorry, let me highlight our answer too, just because I like to do that. Makes it very easy to see where we're going. And I'm just going to say, we have 2 more slides of expanding, so they gonna get longer. All right, this time we've got a natural log of 3wx squared over y to the 4th. Where am I? And again, we're going to start with our division, starting with our quotient property. Got the, wrong pen. Try that again. The natural log of our numerator, 3wx squared, minus our denominator, the natural log of y to the 4th. Then I'm going to come work with what was my numerator and split apart all that multiplication. Ooh. So we're going to have the natural log of 3 plus the natural log of w plus the natural log of x squared minus the natural log of y to the 4th. And we have one more step. Because now we need to do our power property on these 2 exponents over here. And our final answer is going to be the natural log of 3 plus the natural log of w plus 2 natural log of x minus 4 natural log of y. Ooh, and I might have to squeeze that nice and compact. We love that. Gives us plenty of space for the next one. Because the next one gets long. Yeah, I can write your pass.
Very long.
It's very, very long. And we still have 2 more slides after it.
Oh, God. I'm guessing there's going to be one that's just the size of the page.
Yeah. Okay. How are we feeling on our expanding stuff? Not too bad. It's just kind of tedious once we get the hang of it. They get long though. Next one gets real long. All right. So what's our first property we're using? The quotient property. We got to get rid of this division first. So we're going to have log of my numerator, 9v to the 5th x minus the denominator, log y squared w to the 4th. Then what are we going to do? our product property. And we have about a gazillion. And we have to be super duper careful. Because we need to remember this is subtracting this whole chunk. So I'm going to put parentheses around it when we expand it with our product property. And I'm going to jump down here just so I have a little extra space. Log of 9 plus log of v to the 5th plus log of x. I'm actually doing okay space-wise. Minus, and I'm just going to put parentheses around it so we don't have to worry about signs right now. Log of y squared plus log of w to the 4th. Okay, I actually did okay space-wise there. All right. Because what we need to make sure what happens when we get to our fully simplified form with no parentheses is that both of these wind up with a minus sign. So I'm just putting parentheses around them to help us remember, yes, this is turning into addition, but the whole chunk is still being subtracted. So as we apply our product property, or our exponent property, and we're going to distribute through this minus sign, our final answer is going to be log of 9 plus 5 log of v plus log of x minus 2 log y minus 4 log w. Because we have to subtract this whole thing. We have to subtract the whole thing. The whole thing's in the denominator, so they both need to have minus signs. So if you are expanding after a division, I highly recommend using parentheses there. Okay, so that one's our longest one so far. Ominous dun dun dun. To be fair, we only have one more slide of expanding.
How much worse can it get?
Let's find out.
Okay.
Okay, so the left one's not super different from what we've been doing. We're just going to be applying things in a slightly different order because of all these parentheses in here. Because with these parentheses, what we need to do first is actually our product property. I need to get these two pieces separated. Because my outsidiest operation is this multiplication. So we're going to have log base 6 of 2x quantity squared plus log base 6 of y to the 5th. With this set of parentheses over here, before I can use my product property on the 2x, I have to use my power over here. So we need to use our power property first to get 2 log base 6 of 2x plus, and you can use your power property on this side. This side's just about done. 5 log base 6 of y. Now I have my parentheses gone here and I can split these two pieces apart. 2, but we're splitting it after it's been multiplied, so I'm going to put it in parentheses right now and we can see what's going to happen. Log base 6 of 2 plus log base 6 of x and 5 log base 6 of y. But when we're fully expanded, I don't want any parentheses in here. So what are we going to do with this 2? Distribute it to both logs. So we have 2 log base 6 of 2 and 2 log base 6 of x and 5 log base 6 of y. So watch out for the order of operations. They will try and trick you with that. You gotta watch out for those tricksy bits. And then the right one, which looks super duper gross. We can do it, I promise. Because I'm going to just start with my quotient property on this one. Log base 5 of the cube root of x squared plus 1 minus log base 5 of x squared minus 1. So we're just going to start with our quotient property. But then we can make that choice of, well, I'd really rather not have it be in the cube root. Let's put it as an exponential. Log base 5 of x squared plus 1 to the 1/3, right? Minus our log base 5 of x squared minus 1. Well, now I can use my power property and get this guy down here. 1/3 log base 5 of x squared plus 1 minus log base 5 of x squared minus 1. Can I expand out these that have addition inside or subtraction? They have to be multiplied or divided or raised to a power, right? Can I write either one of those as a product? Meaning, can I factor either one of those? This guy's the difference of perfect squares. That one's not. That one's going to have imaginaries. We're going to leave that. We're not doing imaginaries and logs. Ew.
Will we ever?
No.
Okay, good.
At least not in here. Ew. But we can rewrite this x squared minus 1 as a product. This can be factored. 1/3 log base 5 of this guy over here. He's a mess. And we can write this as log base 5 x. Our factored form is going to be x plus 1 times x minus 1, which means I need a little bit more space on my slide. I'm going to change the view so you can actually see, I promise. And I'm gonna give us a little wall over here because I don't like how close those are getting. Because we have one more step we can do here. Now that this is written as a product, we can use our product property and split that one more time. Told you these were gonna get gross. 1/3 log base 5 of x squared plus 1 minus log 5 of x plus 1 plus log base 5 of x minus 1. And remember, this whole chunk was subtracted, so we have one last step to distribute that minus sign. The whole chunk was subtracted. So 1/3 log base 5 of x squared plus 1 minus log 5 of x plus 1 minus log 5 of x minus 1. So we can see as much as possible. There we go. So they can get grossy, grossy, grossy. Okay. What we will do next is work the other direction. And we'll just do a couple of condensing, like probably just 1, maybe 2 slides, because it'll start really, really simple. And we'll get into the gross ones tomorrow. Because then we're going to start working the other direction and taking these big, long, gross ones and getting them down to one single solitary log. Probably we'll just have time for these, because I want you guys to be able to write them down. Because our next step is to condense them. If I give you a really long one, I want you to be able to write it as one single log. So if we have 2 log x plus 7 log y. What are we going to do first to condense it? If we go the other direction, powers. I'm going to take these multipliers. Ooh, now I can put this back on you don't have to zoom in to actually see me right now. Bring these back up as exponents. So we're going to have the log of x squared plus the log of y to the 7th. Condense them again. Addition becomes multiplication. So we'll have the log of x squared times y to the 7th. The whole point is to have fewer logs. When we're done condensing, we should have just 1 log. Just 1. That is fully condensed. This right one will be the last one we do today. And again, we're going to start with our powers. Ooh. All of these coefficients go up and become powers on their variables. So we're going to have log base 5 of z to the 6th minus the quantity log base 5 of x to the 7th plus log base 5 of y to the 8th. Next, we have addition becoming multiplication. Log base 5 of z to the 6th minus log base 5 x to the 7th y to the 8th. Our addition becomes multiplication. And then we're going to use our quotient, where our subtraction becomes division. So we're going to have log base 5 of the fraction. My numerator is my z to the 6th. My denominator is x to the 7, y to the 8. That's a z, not a 2. All right, tomorrow we'll get into some uglier condensing ones. And then what to do if we would really like to be able to calculate things in a calculator, but they've given us a weird base. So we're going to use the change of base property. The change of base? Change of base always makes me think of ace of base, and we're going to go, don't go chasing waterfalls.
Times my mom has forced me to watch that. Like she's a music video person for music, and there's just a few that she just like. And the dancing ladies, the ladies, and she's just hanging out.